Notice how much camera work impacts how a film
Oh,
feels?
absolutely. Yeah.
Like you think about those really tense moments where the camera just slowly glides towards the character,
Right.
just like draws you in,
Right.
and it makes you feel that tension so much more.
Yeah.
You think about those big establishing shots where you've got this huge landscape
Right.
and the camera just like sweeps across it.
Yeah.
You get a sense of the scale in a way that you just couldn't otherwise.
Yeah. It's all part of the language of film. Yeah.
Exactly.
Yeah.
But it's so interesting because I feel like we don't often consciously think about how much camera movement is shaping our experience.
It's true. Yeah. We just sort of absorb it
Yeah,
as part of the storytelling. And
exactly.
it really does affect, how we interpret a scene.
Yeah, totally.
It can change our focus, our emotions, even our understanding of like the space and time within the video.
Totally. But what happens when you finished filming, everything's packed away,
Right.
and then you realize, like, oh, the camera work isn't quite right.
Oh.
Traditionally, that's a pretty big problem.
Yeah.
You're talking about expensive reshoots, you're talking about a lot of time.
It could be a huge headache.
Exactly. But what if there was a way to change the camera work after the fact?
I mean, that would be a game changer, right?
It totally would. And that's what we're diving into
Oh,
today.
wow.
We're going to be looking at this new framework called ReCamMaster.
Okay.
It's all about being able to manipulate video after it's already been recorded.
So basically, you can take existing footage and like reposition the camera.
Exactly.
Wow.
You can create whole new perspectives and movements as if they were part of the original shoots.
That is wild.
So for this deep dive, our mission is to really get under the hood of this technology.
Okay, sounds good.
We want to understand the core innovations driving this
Right.
technology, the specific technical advancements that make it work,
Mm-hmm.
and ultimately what kind of impact this could have on the future of video creation and editing.
I'm all here.
So we'll be focusing primarily on the original research paper for this framework,
Okay.
along with some supplementary notes that we have
Got it.
to give us a bit more context on the development process.
Makes sense.
So for everyone listening in, I think this is a really cool chance to get up to speed on a truly cutting-edge development
Yeah.
in video technology.
Absolutely.
And we'll be breaking down some of the more complex ideas,
Right.
highlighting the key innovations that make ReCamMaster such a big step forward.
Awesome. I'm excited to learn more.
Me too. So the research paper starts by pointing out something really interesting.
Okay.
They say that while there's been a lot of excitement around AI that can generate whole new videos from text or images,
Right. Like those text to video models we've talked about before.
exactly, or even AI that can control virtual cameras in those generated scenes.
Yeah.
The idea of actually changing the camera trajectory in an existing video has been surprisingly underexplored.
That is interesting. I guess it's kind of a different problem.
It is. It's a lot more technically challenging.
How so?
Well, when you're generating something new, you're starting with a blank slate. But when you're working with existing footage, you have all these constraints. You've
Yeah.
got the original content, the existing motion of objects, the established viewpoint.
Yeah.
So the challenge is to introduce new camera movement while still keeping everything looking believable.
Makes sense.
And like everything still needs to be spatially and temporally consistent, even as the perspective is shifting.
That sounds really tricky.
It's a much more constrained problem than just generating something from scratch.
I can imagine.
And arguably a more complex one.
Right.
And this is where ReCamMaster's core innovation comes in.
Okay.
They figured out a way to leverage these powerful pre-trained text-to-video models.
Those AI systems that can basically conjure up videos from just a text description?
Exactly, but instead of just using text as the input, they've developed this really clever way to condition these models on an existing video
Okay.
to achieve this re-rendering with new camera paths.
So they're kind of repurposing the generative power of those text to video models.
Precisely. It's like they're saying to the model, hey, you know how to create video.
Right.
Now take this specific video and reimagine it as if it was filmed with this different camera movement.
I see. So the innovation is really in how they're feeding in that existing video information.
Exactly. And that's what leads us to what they call their frame dimension conditioning technique.
Okay.
Now, this might sound a bit technical, but the underlying principle is actually pretty ingenious.
Okay, I'm listening.
So they start with the source video and the target video, the one with the new camera movement that they want to create.
Okay.
And they represent each of these videos as sequences of what are called latent tokens.
Latent tokens.
Yeah, think of them as kind of like highly compressed digital blueprints
Okay.
that capture the essential visual information of each frame.
I see.
So they're a much more abstract and efficient representation than just using the raw pixel data.
Right.
And then ReCamMaster does this really crucial thing.
What's that?
It concatenates these latent tokens from the source video
Okay.
with the latent tokens of the target video
Okay.
along the frame dimension.
The frame dimension.
Yeah, so rather than just kind of stacking them side by side like you might with layers in an image,
Okay.
they're basically interleaving them frame by frame within this abstract latent space.
So like frame 1 of the source video is next to frame 1 of the target video.
Exactly. And then frame 2 of the source video is next to frame 2 of the target video, and so on.
Okay.
And this combined sequence of latent tokens is then fed into what's called a diffusion transformer,
Okay.
which is the heart of their video re-rendering framework.
Got it.
Now, what's so clever about concatenating along the frame dimension is that the model can now directly compare
Okay.
the content of a specific frame in the original video with the corresponding frame in the re-rendered video.
Within this latent space.
Exactly. And this helps the model learn those intricate spatiotemporal relationships.
Like how objects move and change over time.
Exactly. And because it's learning these relationships in this integrated way,
Right.
the whole model architecture can then process this combined information much more coherently.
Interesting.
So it's understanding the link between the original and the desired output throughout its entire process.
I see.
And the researchers are very clear about how this is different from previous attempts at video manipulation.
Okay.
So some older methods might have tried to combine the source and target video information along the channel dimension,
Okay.
which, as you said, is like adding more color channels to an image.
Right.
Or they might have tried to process different camera viewpoints completely separately.
And then try to stitch them together later.
Exactly. And the paper shows that those techniques often led to problems.
That's what kind of problems?
Well, conditioning along the channel dimension often resulted in visual artifacts and inconsistencies in the generated content.
So the new content didn't really match the original?
Exactly. And the methods that treated different viewpoints separately really struggled with keeping the motions synchronized.
Oh, right. So things might be moving at different speeds or in disjointed ways.
Exactly. And figure 5 in the paper shows this really clearly.
Got it.
You can just see how those baseline methods really suffer from these issues.
So this frame dimension conditioning seems like a key innovation.
It really does. It allows for much better synchronization and overall visual consistency.
Because the model is processing the source and target information in this interleaved frame-by-frame way.
Exactly.
It can really learn those temporal dependencies.
Exactly. And it does this through its 3D attention mechanisms.
Okay.
So it's really a subtle change in how the data is structured for the model,
Right?
but it leads to a huge leap in the quality and coherence of the re-rendered video.
That's pretty amazing.
And the authors even mention that while this kind of token concatenation has been used successfully for image-to-image translation,
Okay.
its potential for this kind of sophisticated video control hadn't really been explored before.
So they've really taken an existing idea from a different domain and adapted it to solve this much more complex video problem.
Exactly. And I think that's a great example of how creative application of existing ideas can lead to these big breakthroughs.
Absolutely.
Now, to train a model that can do this kind of video re-rendering, you need a ton of training data.
Of course.
Specifically paired video data showing different camera angles of the same scene, all recorded at the same time.
Right, to show the model how the scene looks from different perspectives.
Exactly. And the paper emphasizes how difficult and expensive it is to get this kind of real-world data.
Yeah, I can imagine.
Existing multi-view video datasets just weren't good enough for what they needed.
Especially in terms of the variety of camera movements. Exactly. So what did they do?
They took a really ambitious approach. They built their own dataset from scratch
Wow.
using Unreal Engine 5.
That's impressive.
They essentially created this whole virtual production pipeline. So
Okay.
they designed these really detailed 3D environments.
Right.
They populated them with animated characters doing all sorts of things.
Okay.
And then they simulated filming these scenes with multiple virtual cameras.
Each with its own movement pattern.
Exactly.
That's pretty clever.
It is. And they called this dataset multicam video.
Okay.
And it's massive.
How massive are we talking?
We're talking 136,000 videos.
Wow.
Spanning over 13,000 unique scenes.
Okay.
Within 40 high-fidelity 3D environments.
And all those different camera movements you mentioned.
Exactly. Panning, tilting, translations,
Yeah.
arc shots, even randomized movements.
All designed to mimic real filmmaking.
Exactly. And Appendix B of the paper actually goes into a lot of detail about how they created all these different camera trajectories.
Okay.
They had all these rules for automatic batch generation.
I see.
And they even include variations in speed to make it even more realistic.
Wow, so they really went all out.
They did, and it wasn't just about getting a ton of data.
Yeah.
They really focused on making this synthetic data as close to real-world footage as
To
possible.
bridge that domain gap.
Exactly, because they knew that if they trained the model on data that looked and moved like real footage,
Right.
it would be much better at generalizing to real-world applications.
Makes sense.
And they actually did a study to see how much of a difference this made.
Okay.
And it's detailed in Appendix C.1 and Table 5.
Right.
And the results are pretty convincing.
What did they find?
They found that when they trained the model on their multicam video dataset,
Okay.
the re-rendered videos were significantly better.
Then when they trained it on a less comprehensive data set.
Exactly, both in terms of visual quality and consistency.
So the quality and diversity of the training data really does matter.
It's crucial.
That's fascinating.
Okay, so they've got this innovative frame dimension conditioning technique.
Right.
And they've created this massive high-quality data set for training.
Yeah.
So the next question is, how do they actually tell the model what new camera movement they want?
Right. Like, how does the user specify the new camera path?
Exactly, and that's where camera pose conditioning comes in.
Okay.
So ReCamMaster conditions the video re-rendering process on the target camera trajectory.
Meaning the desired path and orientation of the virtual camera.
Exactly, and this trajectory is defined by a sequence of rotation and translation matrices.
For each frame of the video.
Right, it's very precise.
Got it.
But here's a really interesting design choice they made. They decided not to condition the model on the source camera trajectory.
So they don't need information about the original camera movement.
Exactly, and there's a very practical reason for this.
What's that?
Trying to accurately estimate the original camera movement from a single real-world video is incredibly different.
Even with their best algorithms.
Even with the best algorithms.
So by just focusing on the target camera trajectory,
Right, which the user provides.
it makes the system a lot more user-friendly.
Exactly, and it means you can use it in a lot more real-world situations.
Where you might not have that information about the original filming setup.
Precisely so. To feed this target camera information into the model,
Right.
they use what's called a learnable camera encoder.
A camera encoder.
Yeah, it basically translates those numbers representing the camera's rotation and translation
Okay.
into a set of visual features.
That the diffusion model can understand.
Exactly.
That's clever.
And this camera encoder is integrated into each transformer block of the model's architecture.
Okay.
So it's allowing for this really fine-grained and continuous control of the camera movement.
Throughout the entire generation process.
Exactly. Now we've talked about the architecture and the data, but creating a model that actually works well
Right.
requires a lot of careful thought about the training process.
Of course.
And the ReCamMaster team used a few interesting strategies to enhance performance and generalization.
Like what?
Well, one thing they did was to only fine-tune certain parts of their pre-trained text-to-video model.
So they didn't retrain the whole thing.
Exactly. They specifically focused on the camera encoder and the 3D attention layers, and they kept the rest of the model's parameters frozen.
I see.
And the reasoning there is that they wanted to leverage the base model's existing ability to generate realistic video content.
It already knows a lot about visual appearances and dynamics.
Exactly. And then they could just focus on training the new components to handle the camera control.
That makes sense.
Another interesting thing they did was to add a bit of noise to the conditional video latent during training.
Add noise. Why would they do that?
It might seem counterintuitive, but it's actually a common technique.
Okay.
It helps to make the model more robust and better at generalizing to new data.
By forcing it to learn how to deal with imperfections.
Exactly. It basically helps the model learn to denoise and reconstruct the target video, even if the input is a bit messy.
I see.
Which is important because it helps to bridge the gap between their synthetic training data and real-world video.
Right. Real-world video is always going to be a bit messier.
Exactly.
So this noise helps the model deal with that.
Exactly. And then perhaps the most interesting thing they did
Okay.
was to unify different camera control tasks during training.
What do you mean by unify?
So in addition to this core photo-to-video re-rendering task,
Right.
they also trained the model to do text-to-video and image-to-video generation.
With camera control.
Exactly. And they would switch between these different tasks randomly during training.
Okay.
And the idea here is that by exposing the model to these related but different tasks, it helps it develop a more general understanding of how to generate and manipulate video based on camera movements.
I see. So it's not just learning one specific trick.
Exactly.
It's learning broader principles that it can apply across different input types.
Precisely. And figure 9 in the paper shows this really nicely. You can see how the model can take a text description, a still image, or an existing video.
And generate new video with controlled camera movement.
Exactly.
That's really impressive.
And the paper highlights some really exciting potential applications of this technology.
Beyond just changing the camera angle after the fact.
Exactly.
Well,
Well, one really practical application is video stabilization.
oh, right. So if you have shaky footage, you can just tell ReCamMaster to smooth it out.
Precisely. You just tell it to re-render the footage with a static camera trajectory.
And it gets rid of the jitter.
Exactly, while preserving the content of the scene.
That's awesome.
And another really cool application is video super resolution.
Okay.
So by providing a zoom-in camera trajectory,
Right.
ReCamMaster can actually enhance the detail in the video.
So it's like a digital zoom that actually creates more detail.
Exactly. It's not just magnifying the existing pixels.
Generating new ones.
Exactly.
That's wild.
And then perhaps the most intriguing application
Okay, tell me more.
is video outpainting.
Video outpainting.
Yeah, so by specifying a zoom out camera trajectory,
Okay.
ReCamMaster can generate new visual content in areas that were originally outside of the frame.
So it's like expanding the scene beyond the original boundaries.
Exactly. And figure 6 in the paper has this really compelling example
Okay.
where they show the virtual camera zooming out. And the model is convincingly generating the lower parts of characters and the ground.
Which weren't visible in the original video.
Exactly.
That's amazing.
So these applications really show how transformative this technology could be.
Yeah, it's not just about fixing mistakes.
Right.
It's about opening up creative possibilities.
Exactly. You can enhance, repurpose, even expand existing video content in ways that just weren't possible before.
That's really cool.
Now, obviously, the researchers wanted to make sure that their approach actually worked.
Yep.
So they did a bunch of experiments to compare it against other state-of-the-art methods.
Okay.
And they used a whole suite of quantitative metrics to evaluate the results.
To measure things like visual quality and camera accuracy.
Exactly. They looked at things like FID and FVD scores to measure visual fidelity. Clip scores to see how well the generated video aligned with a given text description.
Right.
Camera error metrics to assess the accuracy of the camera movement.
Makes sense.
Synchronization metrics to see how well the generated video matched the timing of the input. And even more holistic evaluations using the VBench benchmark.
Wow, they really covered all the bases.
They did, and the results were really impressive.
How so?
Across all these different metrics, ReCamMaster consistently outperformed the other methods.
That's pretty convincing.
It is tables 1 and 2 in the papers, lay it all out.
Okay.
And it's clear that ReCamMaster is producing higher quality video with more accurate camera trajectories and better temporal synchronization.
That's awesome.
And the qualitative results, the actual video examples they show in the paper, are also really compelling. You can just see how ReCamMaster is able to maintain better visual consistency with the original video.
Right.
And create these smoother, more believable camera movements.
Yeah.
And generate more plausible content, even in challenging scenarios.
So it really is a step up from previous methods?
It really is, but as with any research, it's important to acknowledge the limitations.
Of course.
And the ReCamMaster team is very upfront about this.
What are some of the limitations?
Well, one of the main ones is the computational cost. This phrase dimension conditioning technique is great for performance.
Right.
But it does mean the model has to process a lot more data.
Yeah.
Which leads to higher memory usage and longer processing times.
I see.
And they also point out that because ReCamMaster builds on a pre-trained text-to-video model,
Right.
it inherits some of the limitations of that base model.
Like what kind of limitations?
Well, for example, it can sometimes struggle with generating fine details in complex actions.
Like hand movement.
Exactly, or with consistently rendering small or fast-moving objects.
Okay.
And they actually show some examples of this in Figure 10.
Right.
But I think these limitations are actually really useful.
How so?
Because they point to directions for future research.
I see.
Like finding ways to make the framework more computationally efficient.
Right.
And improving the generation of fine details and handling tricky object dynamics.
Yeah, it'll be exciting to see how this technology evolves.
Definitely. So let's take a step back and summarize what we've learned about ReCamMaster.
Okay.
Essentially, it offers this entirely new way to approach video editing.
Right.
Instead of being limited to the original camera work, you can fundamentally reimagine the perspective.
Using camera-controlled re-rendering.
Exactly, and this is made possible by their innovative frame dimension conditioning technique.
Which allows the model to understand how the video changes over time as the viewpoint changes.
Precisely, and by cleverly leveraging those pre-trained video generation models.
Right.
And their custom-built multicam video dataset was essential for training the model.
Yeah, to give it enough data to learn how to generate video from different viewpoints.
Exactly, and their practical focus on just the target camera trajectory
Makes the whole thing much more user-friendly.
and opens it up to a wider range of real-world applications.
Totally. And we've seen that this technology has the potential to go way beyond just fixing camera mistakes.
Right.
Those applications in video stabilization, super resolution, and outpainting,
Are really exciting.
they point towards a future where we can manipulate video in ways we never thought possible.
Exactly. And it really makes you wonder how this kind of technology could change how we approach filmmaking and content creation in the future.
It's a fascinating thought.
It really is. And for anyone listening who's interested in diving deeper into the technical details or seeing more examples of what ReCamMaster can do, we highly recommend checking out the research paper and the project webpage.
We'll include links in the show notes.
Exactly. Thanks for joining us for this deep dive.
It was a good one.
I thought so too.
Very informative.
Definitely cutting edge stuff.
Absolute.
See you next time. See?